We can use the method of induction, right, for something like this, even though it's like, oh, I don't really know all that much about this, but we can see how it works and how it pans out. So let's give the first one a go, shall we? This is what we want to prove. X to the n minus 1 is divisible by x minus 1. Now, I'm just going to pause there for a second. Okay. This is interesting because if I just stop there, you could prove that. You can prove that. Okay. How would you prove it? You don't need induction to prove that. Come on, think about it. You could do it by exhaustion. There's a simpler way. There's a simpler way, isn't there? All of these things, right? So x minus 1, x squared minus 1, x cubed minus 1, and so on, right? They're very predictable, right? How would you prove that something is divisible by x minus 1? You know a theorem for this. You know the factor theorem. You learned this years ago, right? What does the factor theorem say? If you take the 0 that corresponds to this, which is 1, right? If you stick 1 into this and you get 0, you'll get a factor. Ta-da! There it is. Okay? I suppose if I had rewritten it and said, prove that x minus 1 is a factor of x to the n minus 1, you would have recognized it a little easier. But factors, divisibility, they're the same thing, just two different angles. Okay? But then they throw a spanner in the works. They say, forget that. Okay? They take your only option and they say, get lost. Do it some other way. Okay? Which we can. Okay? So how do we do it? What do we want? We want all positive integers. Oh yeah. Okay? So you tell me, what's the first step? Test. Okay? So you stick it in. You get x to the 1 minus 1. Well, I'm not going to go division on it because I think it's divisible by x minus 1. I'm just going to go with it, okay? True for the first allowable value. Okay, good. Now what? Assume. Now what should I assume? Because just like the divisibility proofs with numbers, right? I haven't given you a straight equation, right? So what could you write? I'm assuming it's true for this value, n equals k, where k follows the same rules that n does. Okay. Any suggestions? What would it mean if this were divisible by this? I'll start with having a k in there, right? X to the k minus 1. What statement can I make about this mathematically that would be equivalent to this? What should it be equal to? It should be x minus 1 multiplied by some other polynomial. Who knows what it is? Who cares what it is, right? If there's a polynomial over there, okay, that's a factor, which means it's divisible. Okay, that's divisible. I suppose I should say where p is a polynomial, just in case it's ambiguous. Okay. Now what? Prove. Okay, I want to prove, right? I want to prove it for the next case. N equals k plus 1. What does it look like? X to the k plus 1 minus 1. I still want that to be a factor. It'll be something else. Who knows? But something else. Right. Now, what can I do to this thing? Even though it's all x's, it is remarkably similar to what you've been doing with numbers. Right? I'll start with the left-hand side again. It's x to the k plus 1 minus 1. Yes? Okay. Now, I need to do some simplifying here, but I'm not simplifying blindly in any direction, right? In fact, if I was just thinking about simplifying, looks pretty simple to me, right? I don't have to do anything to it, but I want to do something to it for what reason? What am I trying to work toward? I need to use this, don't I? I need to bring it into play somehow, okay? So any suggestions? What should I do? What did I do last time? I had a 4 here, didn't I? Okay. and I said, well, I've got 4 to the k plus 1, but I want a 4 to the k, right? I know it looks different, but it's not. X is some number like 4, whatever it is. I just know it's not 1. Okay? I can do exactly the same thing. Our index laws tell us that that is equal to x times x to the k minus 1. Okay? Am I in position to use my assumption yet? I'm pretty close though, aren't I? Pretty close. Okay? I don't want x of those. I just want 1. Okay? So let me just put one over here for a second. There's one of them. Okay? So if I took out 1, how many will be left over? The x minus 1. In our case before it was 3, wasn't it? X minus 1. Oh, that's convenient, right? That's how many x to the k's I have left, and I'm adding that. Now I can use my assumption. That's x minus 1. And what did I say that was equal to? X minus 1 times some other polynomial. Okay, you can see I've done the hard work now, haven't I? Okay, take your, by assumption. Okay, so I take my factor out, and now you can see what Q is, right? Or at least you can see what it is in terms of P. There you go, there he is. Okay, that is Q. And you're fine from there. Okay, make your explanation, and you're finished. Okay? So, this is where you look at this, how many numbers are on the board? Well, there's some 1s, and that's about it. So your mind starts to spin out a little bit when you're like, so many letters, okay? But don't be too afraid. Just think about it in terms of, we did it with numbers and it was no trouble. So you can do it with algebra.